Welcome to the deep dive. Today, we're going to get into some really high-end AV infrastructure. We're looking at how to solve the biggest problems in video distribution, things like distance and lag.
Yeah, and we're talking about a scale that most people, never even have to think about.
Exactly. Our source material today is a fascinating piece of hardware, the WolfPack 4K30 fiber output card. And our mission is really to figure out how this one little card makes huge, complex AV systems work seamlessly.
And the most surprising thing, right off the bat, is the distance. This card can push a perfect 4K 30 video signal up to 6.2 miles.
6.2 miles.
That's 10 kilometers over a single strand of fiber optic cable.
That is just incredible. Okay, so let's look at the actual hardware. We're talking about the 4K30 fiber out card. It's a one-port output card for WolfPack's big modular matrix switchers.
Right, the 9x9, 18x18, all the way up to the 36x36 chassis.
And the price listed is around $250. Now, wait a second. A huge enterprise system like that is relying on a $250 part. Is that right?
It is, and that's actually the whole point. It's about modular efficiency. The genius of the slide-in card design is all about maintenance.
Okay, so if a signal drops out...
If a signal drops 6 miles away, you don't have to rip out the entire matrix switcher. You just, pop out the old card, slide in a new one, and you're back online in seconds. It cuts downtime massively.
Right. And technically, it's giving you 4K 30 with no latency all through a single LC connector.
Exactly.
I did notice a small conflict in the sources about the bandwidth. One spec says 10.2 GBps, but another says 6.75. What's going on there?
That's a great question. It's usually the difference between, let's say, the theoretical maximum and the practical stable bandwidth.
Okay.
10.2 is what the fiber can handle, but 6.75 GBps is what's actually needed to run 4K 30 video, plus all the protocol overhead with rock-solid stability. The system is engineered for that stability.
And stability brings me to the biggest pain point in AV, that black screen of death.
The dreaded black screen.
Yeah, that 2 or 3 second delay when you switch inputs. I saw their proprietary tech, Swift Switch, claims to switch in 100 milliseconds. How? How is that even possible?
That 0.1 second switch is the real magic here. It gets rid of the black screen by doing all the technical handshakes before you even see the switch.
The handshakes, you mean like EDA and HDCP?
Precisely. EDA is the display telling the source its capabilities, and HDCP is that copyright handshake. Swift Switch does both of those negotiations for the source and the display at the same time, in parallel.
Okay, so it's happening simultaneously.
Yes, and crucially, it uses an internal frame buffer. It's already holding the information from the input signal. So the new signal is primed and literally just waiting to be sent out.
So you get a clean frame-to-frame cut.
A perfect cut. And that's what commercial venues, that's what they pay for. Uptime's everything.
Speaking of those venues, where are we actually seeing this tech deployed? I mean, who needs this level of perfection?
Think of anywhere a glitch costs money or creates a security risk. So casinos for their surveillance feeds, data centers for monitoring, big conference rooms, even places of worship with those giant video walls.
Right, places where you just can't have a signal drop.
Never. Reliability over huge distances is the key.
And for those kinds of installs, control integration has to be perfect too.
Absolutely. Beyond the basic front panel or web GUI controls, they give you the full RS-232 script.
So AV pros can write their own drivers for the big systems, like Crestron or AMX.
Exactly. Crestron, AMX, Control4, you name it. They can write a simple, clean command to manage really complex switching patterns.
So if I want to switch input 8 to, say, outputs 1, 8, and 16, the command is just by 1 and 8 and 16.
That's it. It simplifies the whole process. And this is a really important technical note.
Okay.
You absolutely cannot mix these fiber cards with the standard 4K 30 HDMI cards in the same chassis.
Ah, so you have to choose all fiber or all HDMI. Why is that?
It's all about timing. The digital clocks and the signaling protocols for sending 4K over pure fiber are just, they're highly specific. Mixing them with copper-based HDMI in the same box creates synchronization conflicts the system can't resolve. It's built for one or the other.
Got it. Okay, so to wrap this up, there's also a 2-year WolfPack care warranty. They'll ship a replacement within 24 hours if a card fails.
They will. And that brings this all together, and it leads to, I think, a really interesting final thought for you, our listener.
Okay.
Given how incredibly sensitive digital protocols like HDCP and EDE are to any kind of corruption, what kind of specialized, optical to electrical signal regeneration must be happening in the receiver box 6.2 miles away to manage and stabilize those handshakes without a single error?
Yeah.
That's a whole other deep dive right